Hello everybody. We try in this part of our lecture to give a general idea about the database. What is a database? Also, we will present some instructions of SQL. SQL, it is a language to manipulate data, to create the database and to modify database. In this course, we told you before that when we started to use the computers, at the beginning we used the computers to calculate. So during the years 1950, we used the computer to calculate algorithms, to treat data, but the data were numbers. In the same time, as we presented in this course also, we used telegraph, we used Morse code in order to communicate message and letters. By that time, the Morse code was developed in order to create some standards to send texts between cities and states. These standards were used during the Second War. We used a tool that we call teleprinter. With teleprinter, we could communicate text for long distances in the same time where we used the computer. So it was normal to start to think how we will use these codes in computer in order to register data. During the year 1963, we invented in the USA the code ASA. It is a standard to define the letters and the main symbols to communicate texts. Furthermore, this code contains some control elements, some control symbols that were very important to communicate the text, such as go to the next line, end of line, start a new message, etc. In 1965, this code was used by the huge company, the most important company during this period, and up today perhaps it is one of the most important reference in computer. It is IBM, International Business Machine. It is the enterprise who invented the PC, personal computer, in 1981. This enterprise adopted the code ASCII in its PC, in its personal computer, and this computer was distributed over the globe with the ASCII code. So this computer was able to treat texts. ASCII is American Standard Code for International Interchange. So from the beginning we see that the idea of a global code exists. Since Morse code, we talked about that in the first lecture in our course. Even if computers were able to treat text since the end of the 1970s, but treatment of text was very difficult if we compare it to treatment of text today, treatment of data, because representing data in a file do not enable us to find the relationship between these elements. If we take an example of today, if we put a lot of information in a Word document, imagine that we will write, for example, in a file some information related to a school. We will say that Sophia, it is 1999, it is from USA, its birth was in New York, she lives now in Lille, in some address, and she studied in algorithm, she is in computer science perhaps, and marks was 15 out of 20. The second is Isabel, in the USA, in San Francisco. She lives eventually in Roubaix, in a specific address. She studied information system, a urban information system. She is in civil engineering department, and its mark was in this module 12 out of 20. We have William, etc. We can register this data in a file, but the problem, how we can exchange the data, how can we find a specific types of data? If we store this data in a file today, we need to make many files. One file for examination department, one file for administration. Do we need a file for each professor, for example? If we have one file in the examination service, should each professor come and add some information in the same file, or professor should have a copy of this file? And if a professor has a copy of this file, when he modifies something, what he will do? How will he can update the central version of the file? It is very complex question. If we register data in files, separated files, how we will manage all this complexity? We have, if we want to use search option, for example, how we can add each time the marks of each student, where we should add them, how we can solve these problems, how we can manipulate this data in this file. Imagine that we put all the information of the university of 70,000 students in one file. How can we modify this file? How can we add some information? How we can remove some information? If some student change something, if he get out, if he change the university, what we will do? If we want to update one mark, what will happen? It is impossible to manage 70,000 students with one file, even with hundreds of files. It is very complex to solve the complexity of such a huge system with a database stored in a file. With such solution, the data is isolated. Example, if examinations are separated, how to find students from Lille who took an exam? If we have some specific examination, if we want, for example, to say that student during the COVID-19, students from Lille should come to the university and other students are allowed not to come. How we will find these students in such file? If we use only one file for all the students, it is not easy to find these students. Redundancy, we will have a lot of data that is repeated if we have the name of the student and the birth date and the address. If we have a lot of files in the examination department and in the administration department and with each professor, so these data will be repeated. And there is a weakened consistency. If there is any problem in these files, for example, if we make a mistake when we enter the name of the student or the birth date, we cannot, it is difficult to correct all the versions of this file. The structure of each file is linked to the software used in its sector. If we have different files in different departments, and there is different enterprises who make the information system for these administrations or for these departments, we will have different type of files. We will not have the same structure of files. So each enterprise will propose its proper structure of data. So it will be very difficult to search a data or to find the necessary information. What database management system does? With a database management system, we can store a huge quantity of data. We can store a huge quantity of data. We can share this data. And we have different rights to access to this data. We can manage access to this data. We can manage the consistency and the non-redundant data. So we can be sure that if we make the good design, we can be sure that our structure will be optimized and we will not have a redundancy of data. And these DBMS, usually the design may be implemented by a non-expert people. At the top level, we don't need expert. In ANSE Spark architecture, the proposed model is divided into 4 levels. The first level, it is the users and users with simplified interfaces. The conceptual level, it is also very easy to do, to convert the design using some instructions into a real system to make the relationships between data, to specify these relationships, to write some commands, to search some type of information, to modify this information. All these conceptual instructions may be done by some experience. We don't need deep experience. After that, we have the internal schema of the database, and we have the physical representation of the database, where really we store the data in 1 hard disk, 2 hard disks, 3 hard disks, in the cloud, etc. All this information, all these techniques that need some experts, it is not necessary to be done by a simple user or a simple designer. The database management system allows us to guarantee these. If we have a very complex structure for a bank or another enterprise, we can ask some experts to make the design for these levels. What we will do in this course, we'll have some idea about how to make the conceptual structure, because we worked before in the design. We used UML, for example, and DFD. We'll try to understand how we can convert a part of our design into a database. We'll try to convert our schema in a database at this level, at the conceptual level. SQL, it is a language that allows us to create these tables and to define the relationship between the tables, and to extract information from the tables, and to modify these tables, to feed these tables with data. For example, we have a table, stations. Each station related to a city. It is related to a state. It is related, there is some coordination, longitude and longitude. How we can create this table? It is very easy using SQL, very, very easy. We use create table stations. So it is merely to use the command create table. What is the name table? Stations. And we precise the name of the columns. ID, integer, it is a primary key. What is a primary key? It is one column that may distinct between all the lines. So we will not have the same ID for different lines. And we will use this key to reference this column in the other tables also. So in the other tables, we can use this ID to say that we will, another line in another table is related to the ID number 13 from stations. So we have create table, stations. We precise that we have a column, the name is ID. We have a column city, we have a column state, we have a column LAN in and long W. So it is related to the name of the columns that we see. And we precise the type of these columns. For example, we said that ID it is integer, and we specified that city is from character. At maximum we have 20 character. The state should be only 2 letters. And regarding the reference, the coordination, we use real numbers. These instructions is suitable. We use this instruction to create the column, but the column now is empty. How we can add these lines, how we can feed this table with data. We have another instruction, so we can say that it is from DML, it is SQL, but it is for manipulating data. Insert into stations. This is an instruction. Insert into stations. Values. What values we will add? We should 13, phonics, AZ 33, 112. So this instruction will add the first line in the table. After that, we have the second instruction to add the second line, and we have the third instruction that will add the third line. What is important also, if we add a huge quantity of lines, we can also retrieve our data. We can search for a specific data. How we can do that? Also, we have one instruction from DDL. It is select. It is very, very important and very simple to use. Here we find the difference between a graphical representation of the database. For example, in Excel, we can find columns, but we should find it is not easy to specify the correlations between the elements of the column. If we search a specific information, it is not easy to find it if we don't have a predefined function in Excel. Here, for example, we have select state. We specify the name of the column that we are searching for. From stations, so we say that we need some of the information from one column in a specific table, from the column state in the table stations, and we can specify conditions. We can say where lat n is more than 39. The answer of this question will be this small table. So with one instruction we could find the data. We can join many conditions from different tables in the same instruction. There is two types of instructions, two types of families. The one was DLL, the second was DML. The first was to define the tables, define the structure of the database. The second was to manipulate data, and the third is DCL, data control language. That means we can define also who will use this database, and we can give different rights for these users. What is the relationship between a table and a class diagram? What is a relation? If we take a look to the table, we can find that there is some relation between Charles, Martin, Polytech, Count, 2. It is a line. Each line in the table, it is an occurrence of a relation. There is some relationship. For this reason, we put them in one line. If we took all the lines, we can say that we have a complete representation of the relation student. So, in mathematical language, a student is a relation. The table is a relation. When we talk about UML class diagram, the class was an abstraction of many objects also. So, it is a class. Occurrence, the occurrence of one relation, one line, it is an object. If you remember the difference between object and a class, object, it is a real occurrence of the class, and the class is the abstraction of many objects. So the occurrence in a line, it is an object. If we use the class diagram terms, if we use object-oriented programming terms, the column in the table, what is it? It is an attribute. So we can find the correlation between class diagram and relation in relational database. For example, if we have a student, it is a class, but it is a simplified representation of the class, because if you remember, we have two types of representation of each class. One with the details, with the attributes and with the methods, and the other with a simple representation that we use especially in the analysis. So student is an entity type. It represents the table students. Here, the attributes of the student, the attributes are the columns. So we have the columns, we have the attributes. Each attribute is represented by a column. This is a simplification, because if we have only one class, each attribute would be represented as a column. But if we have a complex system, all the relationship of multiplicity, of the inheritance, will be implemented also as columns. We will find that in the next parts of the lecture. Each line, it is an object. It is entity occurrence. We can remember our module that we fix in the walls. If you remember, we used this module in the connected home system, and we said before that we use this module as a part of the system. We fix it in the rooms or in the apartment, and it measures the temperature, humidity, luminosity, etc. This is a possible representation of this module using SQL. It doesn't mean that it is the correct representation. We should pay attention. It is one of the representation. It depends on our system. What do we need from this module? Create table, module number. So this module will have a number in our system. It will be used as index in our system. Physical number, because we add a number for each module. We can find this number as a reference that was printed on the box of this sensor. Room, that means in which room we will put this sensor. Apartment, it means in which apartment we will put this sensor. Foreign primary key, what is the reference, what is the index that we will use in this table to know this line that represents one of these sensors, one of these modules. It is module number. Foreign key room, reference rooms. That means we have another table, detailed table, records the rooms, and we have a relationship between these two tables. The column room here, it is not a reference for the modules, but it is a reference for rooms. So we can know if our module is fixed in room number 1 or room number 2 or room number 3. But if you want more details about these rooms, we should go to the second number. The name is rooms, and we should find the details about the type of this room and many information about these rooms. The same thing regarding apartment. Here we have an attribute. We have a column. The name of this column is apartment, and the name apartment is related, as we see in the bottom, it is related to a table that we call apartments. So it is the reference. If we want to know where this module is fixed, we know that it is fixed in apartment number 3, for example. But if you want more details about apartment number 3, we should go to that apartment. Also, we added some important information for our project. It is the height in which we fixed this module, because we say that we fix the module in a room or in an apartment, but we know that the height of is very important, because it will measure temperature, humidity, luminosity, and where we put it is very important. We can add a lot of attributes in this representation of our module using SQL, but we will talk about that in the future, because I will tell you how can we convert class diagram into SQL.